Okay, so we know all about radians around the unit circle, but there are some that are special. So I'm going to teach you about the ones that you're going to need to be able to memorize. So your teachers can imagine the unit circle in their head, but at first you might need to draw it every time. So this is going to teach you how to draw the unit circle on the back of your test or wherever is necessary. So you need to be able to come up with this on your own. So I've got my XY axes. And if you're a color coder like me, you'd want to highlight those yellow and then go ahead and cut those quadrants in half. So these yellow lines are going through right through the middle of each quadrant. So for unit circle, we know the center's at 0, 0, and the radius is 1. So at all these spots along the circle, eventually, you're going to need to be able to name them in degrees, in radians, and the coordinates. So I put this big 0 here for you to get started. If the roller coaster is sitting right there, it hasn't gone anywhere, so it hasn't traveled any radians, so it's 0 radians. We can convert these all to degrees later. We're going to do radians for today, but it would also be 0 degrees. But if the roller coaster is sitting right there, this is still an XY plane. What's the coordinate of a point right there? Well, it's 1 over and up 0. So that same spot has a coordinate of 1, 0. So we want both of these, radians and coordinate. There's other spots that should be, quote, easy to fill out the coordinates of. So what about this spot up here? Your intercepts, right? Those should be the easy ones. If your roller coaster was sitting right here, what would be the coordinates of that spot? Well, it's left, right, 0, and up 1, so that would be 0, 1. Sorry for all those notification sounds. What about over here? What would be that location as a coordinate? Well, that would be negative 1, 0. And then finally down here on the XY plane, that point would be 0, negative 1. Okay, these lines that I did. We know the top half of a circle is called pi radians. It's 1 pi. So if I'm just looking at the top half, I cut it into 4 slices. So since I cut it into fourths, we can count by fourths. So this first line going counterclockwise like we do would be 1/4, but we write it as an improper fraction with pi on top. So I'm just counting by fourths. 1/4. This next yellow line would be 2/4, but that reduces, and we always reduce for our final answer. So I'm continuing on 1/4, 2/4. Next would be 3/4. Anybody can count by fourths. This shouldn't be too bad. After 3/4 comes 4/4, but that reduces, and we know that that spot is pi radians. What comes after 4/4? Well, 5/4. Improper, so not a problem at all. After 5/4 would be 6/4, but that reduces. And then after 6/4 would be 7/4. And if he went a full trip around the circle, he would have gone 8/4, which reduces to 2 pi. So the same spot could be named 0 or it could be named 2 pi. So hopefully that wasn't too bad. We cut it in fourths, we counted by fourths. Those were yellow on our unit circle. Same unit circle, so do not draw a new one. This was yellow, our axes were yellow. I now want you to make them green because when you put blue on top of yellow, you get green. Then these are new lines. These are supposed to be a third of the way through that same quadrant. So your picture has a yellow one going right through the middle and these blue ones on each side. So pause your video and add these blue lines to your picture. I need you on your paper to just ignore the yellow line, just like it's not even there on my paper, because we're done. We already labeled that yellow line. The green ones show up both times, but we already labeled that yellow line, so ignore it. If half a circle is really pi radians, I just cut it into sixths. So now I'm going to count by sixths. So the blue and the green, 1/6, ignore that yellow line. 2/6, but that reduces. 3/6, but you probably already have that labeled, right? 3/6 is your pi over 2. 4/6 reduces. 5/6. You already have 6/6 labeled because that reduces the pi. After 6/6 is 7/6. 8/6 reduced. 9/6 is already labeled. 10/6 reduce. 11/6, and then finally 12/6 or 2 pi. So this is how we get all the radians. Why is it cut into fourths and sixths? We'll talk about later, but this helps you label the whole circle. So draw a whole new circle. So I want you to pause the video because it takes a minute. Draw a circle with all the necessary lines. So you start with the axes. Those are green because they count both times. Then right through the middle are my yellow lines for my fourths. And then approximately a third of the way, you draw your blue lines in each corner. Practice being able to just get the lines set up. You don't want more or less lines than necessary. Also, go ahead and label the intercept coordinates that are supposed to be the easy ones. Now, once you get it all drawn, it doesn't matter, but I'm going to start by doing the sixths first. So ignore the yellow line. I'm going to count by sixths, every blue and green line all the way around to get my circle labeled. So here we go, 1/6, 2/6, but I already reduced it, 3/6, 4/6. These are all reduced answers because it makes my circle look less messy. 5/6, 6/6, 7/6. We're ignoring yellow. 8/6, 9/6, 10/6, 11/6, and back to my 2 pi, which is 12/6. Now I'm going to do the fourths, but some of them are already done for me, right? So ignore the blue. So just yellow and green. 1/4, 2/4 is done, so just tap it with your pencil. 3/4, tap the 4/4, 5/4, tap 6/4, 7/4, and tap your 8/4. And now you have a full complete unit circle with radians. The next presentation or next lesson in class will be how to get all the rest of the coordinates. But for today, I want you to be able to label those radians. So here's a blank one. I'm just going to leave it here. Why don't you pause your video and see if you can do it again? And then you have the complete one done so you can check it on your own.